Hello, good afternoon. My name is Pedro Borrero from the University of Malaga. Today, I'm pleased to present the scientific study, evidence of the improvement of the thermal comfort index and habitability in bioclimatic space of the Mediterranean region, authored by Angel Enrique Salvatierra and me, from the Department of Botany and Plant Physiology at the University of Malaga, Spain. The climate crisis is increasing evidently, especially in southern Europe, where projections show a significant rise in temperature by the end of the century. In Spain, maximum summer temperatures are expected to increase by average of 2.3 Celsius degrees. This trend is already noticeable, with a record rise of 1.4 degrees and remarked intensification of heat waves, events that are no longer more frequent and more extreme. Urban areas play a central role in this problem, generating 40% of global greenhouse gas emissions, largely due to current building and urban planning models. In Andalusia, the health impacts are severe. Mortality rates have increased by over 10% for each degree above critical threshold. In the metropolitan area of Malaga and the coastal zone, in 2024 was among the hottest year ever recorded, with extreme heat episode surpassing 44 degrees and over 30 consecutive tropical nights. Throughout history, vegetation has been closely integrated with architecture, offering not only aesthetic and cultural value, but also remarkable bioclimatic benefits, from ancient Egyptian pergolas used to provide shade and cool the air, to Roman summer triclinia and combined vines and seasonal sunlight for year-round comfort. Green architectural systems have evolved across cultures. Roof gardens, inspired by lions, such as hidden gardens of Babylon, emerged of the need to reconnect the city with nature. Based on this heritage and current climate challenge, the concept of bioclimatic climate shelters has gained traction. These are low-energy spaces designed to protect people and biodiversity during extreme heat. Ultimately, green architectural systems offer more than just beauty. They provide essential tools for urban resilience, climate comfort, and public health. This study aims to evaluate the effective traditional architecture structure, specifically pergolas and patios, are mitigating high temperatures. These two elements deeply rooted in Mediterranean culture and widely used across the region. The research focuses on the metropolitan area of Malaga and the coastal zone, and Michael's from here, located in the southern Spain along the Albanian Sea. This area features varied landscapes and mountains and coastline with a subtropical Mediterranean climate, average annual temperatures of 18 Celsius degree and irregular rainfall between 500 and 600 millimeters. Tourism, intensive agriculture, and more recently, information technology dominate the economy. From the comparative analysis, two locations were selected: the Teatinos University campus in Malaga, which represents an urban environment, and Tolvaro Farm in Coim, a rural island site. Both experience a warm, semi-arid climate as belong to the thermo-Mediterranean bioclimatic zone. To assess thermal comfort and climate moderation, variables such as temperature, humidity, UV index, wind speed, and sunrise-sunset times were monitored using data from MeteoBlue. This microclimatic difference help us better understand how green architectural systems perform under real heat stress conditions. For our file study, 6 sampling points were strategically selected at Teatino campus, based on solar exposure, vegetation cover, construction materials, and their potential to exchange environment comfort. These points were organized into 3 categories. The first includes spaces without any mitigation elements, a space that incorporates plant elements that provide shade and improve the topoclimate, a space that combines traditional materials and the presence of water with vegetation. The file sampling was conducted between April 23rd and June 25 in 2024, as shown in the figure. During this period, data were collected on 3 randomly selected days each week, covering 3 key time slots throughout the day to capture relevant thermal variations. For data collection, we used the psychometer with infrared, equipped with infrared thermocouple input, humidity sensor, and laser light. To cross-validate temperature readings, a thermal imaging camera would also employ this non-contact device converts infrared energy into thermogram. A thermal image that reveals temperature distribution on surface, weather emitted, reflected, and transmitted. This dual instrumentation approach ensured accuracy and provided visual support for interpreting the thermal behavior for each sampled space. In the Finca Trobarro in Coin, located in Guadalhorce Valley, Malaga province, spans 1 hectare and features a remarkable diversity range of environmental units. To capture this diversity, sampling points were selected based on the presence of vegetation, water bodies, and constructed shading structures. You can see in the table and the figure. A space like elements that mitigate direct solar radiation with a shade and water, a space with wind shade, and a space with vegetation. The sampling campaign at Finca Trobarro Coin took place in April 2023, specifically of the 13th, 14th, 18th, 19th, 21st, 24th, and 25th, as illustrated in the figure. The dominant winds during these days was Isla Levante, frequently reaching gusts above 25 kilometers by hour. This wind condition contributed to clear skies with only brief and negligible rainfall event on April 2023. Measurements were carried out using the psychometer with infrared, equipped with an infrared thermocouple input and humidity sensor, and a laser light. The sampling protocol involved visiting our selected sampling points each scheduled day in the shortest possible time, following a consistent and systematic route to maintain compatibility across datasets. Climatic comfort is about how people feel the weather in a certain place. And this depends on things like age, health, or lifestyle. To measure it, we use a well-known index, called the Temperature Humidity Index, THE, which shows how the heat and humidity affect our comfort. We adapted this index to better reflect human needs in the local climate. Using data from 2 weather stations, we calculate THE for several sample points. Then we used a special software to group and compare these points and create maps showing how temperature, humidity, and comfort levels vary across the area. This helps understand how the people experience the climate and can guide better urban design. The results clearly show how vegetation and shade significantly improve climate comfort in the Tatinos area, like in the Tatinos station. Areas like Botanical Garden and Pergola, Emperador, and Pavilion A4 showed highest comfort levels. In La Finca Trobarro Coin, shaded areas like Parva, Almes, and Alberca recorded lower temperatures and higher humidity, offering a fresher thermal sensation. You can see here THE results scheme and the Trobarro farm in Coin. So, in conclusion, This study showed that combining vegetation with thoughtful architectural design creates much more comfortable thermal environments. In contrast, areas with high sun exposure and impermeable surface experience greater heat stress. Vegetation, especially when integrated into a structure like pergolas or green roofs, plays a key role in creating low-cost bioclimatic refuge. While buildings like Pavilion Airport offer good climatic comfort, they require high investment. The pergola, however, proves that effective cooling can be achieved with simple, affordable solutions. To improve thermal comfort in problematic areas, we recommended using green walls and roof incorporating traditional Andalusian courtyards. Choosing natural insulating materials like clay or terracotta and adding water features to promote cooling through evapotranspiration. These strategies can help create cooler, heated urban space with minimal resource demand. So thank you so much.